Hi, good morning. In previous video, we have discussed about the analog sensor interfacing. Now we are going to discuss about the digital sensor interfacing under the unit microcontroller and interfacing techniques for IoT devices. Here we are going to interface a digital sensor. Interfacing digital sensor with Arduino is a fundamental aspects of many electronics and embedded system projects. Digital sensors produce discrete outputs typically in the form of high or low voltage. An Arduino with its digital input and output pins is well suited to handle the signals. Here we are going to discuss about the digital sensor interfacing with Arduino. We are going to see these programs like blinking an LED, toggling the state of LED using switch, traffic light simulation for pedestrians, create dimmable LED using potentiometer. First, we are going to see blinking an LED. The components required is one LED, 1 kilo ohm resistors, jumper wires, and breadboard. We are having an LED here that with the cathode and having the two terminal cathode and anode. The longest lead is the anode and shortest lead is the cathode. Here we have connected that LED with the Arduino board. We have connected that pin with the 13th pin in Arduino board, and also we have connected 1 kilo ohm resistor to the 13th pin, and one pin is connected to the ground connection. Here this is the program for blinking an LED. In that we have made the 13th pin as output, and we have created the loop and make digital write as high for 13th pin, and we have to give some delay. Then digital write pin 13th pin to be low, set the LED to low voltage, and we have also given a delay for 1000 seconds. 1000 milliseconds. Here the toggling the state of LED using switch. Here also one LED, 1 kilo ohm resistor, one push buttons and jumper wires and breadboard. Here the open push button mechanism is used. In normal state, the button current does not flow only when the button is pushed. The flow of current is allowed. This is the connection for toggling the state of LED using switch. We have connected that 1 kilo ohm resistor to the switch, then to the 13th pin. Here the switch will allow current only when it is pressed, and it does not allow any current flow when it is not pressed. This is the program for blinking an LED by toggling the state of LED using switch. The pin 13th, here also the 13th pin as output, and digital write as high and digital write as low, and we have connected the only one. The difference between the previous program and in this program is we have connected only a switch. Then we are going to see the traffic light simulation for pedestrians. Here two LED, red color LED, green colored LED, and one yellow LED, and 522 ohm resistor, jumper wires, and breadboard. These are the components that are required for traffic light simulation for pedestrians. This is the connection for traffic light simulation of pedestrians. This is the program for traffic light simulation for pedestrians. We have connected the red LED to 13th pin and yellow LED to 12th pin, green to 11th, and green pedestrian to 2 and red pedestrian to 3. We have to initialize that LED and making it as output. Then we have to write every pin as a high or low based on the time delay. We have to make light to be switch on and off. This is the traffic light simulation for pedestrians. First, digital write green vehicle for a green LED to be high. For at the same time, the red pedestrians to be high. For this, after some delay, we have to make a green LED to be low and a yellow vehicle to be high. And after some delay, yellow vehicle to be high, low, and red pedestrian to be low, and red vehicle to be high. Then after that green pedestrian to be high, there should be some delay, After that, red vehicle to be low, and green pedestrian also to be low. Thank you. And also we have a distance different sensors will be produced with the binary outputs which are either high or low. For examples of digital sensor include simple push buttons and motion detectors, IR sensors, um, and digital temperature, humidity sensor like DH11 or DH12. These are the digital sensors that we can connect with an Arduino board. Arduino digital pins have several digital input I/O pins, input output pins labeled as D0, D2, D1, D2, etc. These pins can be configured as either input or output. When these pins are used, these pins can read the state of a digital sensor either high or low. When used as an output, they can send signal to the controller or other digital devices. Connecting digital sensors. Connect the sensors as an output. Um, we connect the output pin to the Arduino board, and we have to give the some VCC and ground connection to the Arduino board so that it can perform well. Thank you.